Okay, one of AP's favorite question types is rate of change problems, where they give you the rate of change or the derivative and ask you questions about that. Some of those involve integration, others involve other things. So this is one of their favorite types. It is so big on the AP exam that I'm going to spend a whole day teaching this particular application problem because they ask it so much. My first year teaching calculus, I did not teach this one. I kind of skimmed it like here it is and didn't realize how big of a deal on the AP exam it was. And it's huge, so we will do a better job. Last year was my first year. We do a better job now of teaching how to do rate of change. The key to the rate of change problems is to remember that the rate of change equation is the derivative, right? Because we know rate of change is slope, we know derivative is slope, so the rate of change equation is the slope. So that's the big key. So, example number 1. Oil is leaking from a tanker at the rate of R of T equals 2,000 e to the negative 0.2 T gallons per hour, where T is measured in hours. How much oil leaks out of the tanker from time 0 to time 10?
So if it's just how much leaks out, not how much is left.
Right. So how much leaks out of the tanker? So the real world application of this would be if you're how much oil just spilled in the Gulf of Mexico. That kind of application. How much oil is there? So we're wanting to know how much oil leaked out from time 0 to time 10.
Enough to cover the cycles.
Okay. So, how are we going to find that? The integral from 0 to 10. Does everyone agree? Yes. Okay. Just because you're in the middle of a mastery exam, we can talk a little bit about how you do this by hand. We are going to put this in the calculator. To do this by hand, you would need to use substitution on the negative 0.2 T. So you want to take that, so you have to take 2 times dt. You get 1 over negative 0.2. For this problem, it's probably a calculator problem, and you can type the whole thing in your calculator. But I just want to mention that for integration gateway purposes, if you were doing this by hand, you could do substitution on the negative 0.2 T. Okay, and what do we get? D. 1,647 gallons.
Approximately.
Does that make sense that would give you the amount of oil that leaked out from 0 to 10? Now, does that give you how much oil there is, or how much oil leaked out, or how much left in the tank, or anything like that? It just tells you what happened in those 10 hours? 10 hours. Okay, example number 2. The flow of oil in barrels per hour through a pipeline on July 9th is given by the graph shown above. Of the following, which best approximates the total number of barrels of oil that passed through the pipeline that day? So this is the entire day. This function is the barrels per hour, so the rate of change. And so what would give us the number of barrels that passed through the pipeline that day? What am I going to do? It would be the integral. And how am I going to do the integral if I have a graph here? Okay, Riemann sums or just area in general. I'm just going to count boxes.
Boom, what did that tell you?
Not boxes. So, what you do need to know is that each box is
Each box.
600. How do you know each box is 600?
600. Boom, yeah, 600.
So, how many barrels are there? Well, there's 600 4 times, right?
Oh, that's like 2,000 soldiers right there.
Okay, so none of those answers. Perhaps that's one of those two. That's not more than a square up there, is it? Doesn't look like more than a square, does it?
About.
It's about a square. About 3,000. And you notice they didn't put the others close enough to be an issue. That was a real achy problem. Well, I think there's just such a large volume engineering field that those come up after that stage price. A new car called the driver. I didn't make this.
Okay, whatever.
I know. As it's plant next to the dealership, completed cars are moved immediately to the lot to be sold. Suppose that at the start of the month of May, there are 100 cars on the lot waiting to be sold. Cars come off the assembly line at a rate of A of T, and they are sold at a rate of S of T, where T represents the day of the month. For May 1st, it's equals 0, and for May 31st, it's equals 30. Are there more than 100 cars on the lot on May 15th? First. So A of T is the rate that they come off of the assembly line. S of T is the rate that they are sold. Yes. Hey, I hear you typing and doing. What are we doing? What kind of calculus? If I just plug in 15 for A of T, that would be a rate. That would be like cars per day. So that would be the amount of cars per day that come off the lot on May 15th. To get the number of cars, I need the integral. Does everybody agree? Because the number of cars would be the accumulation of the rate over those 15 days. So you tell me, what does this integral give me? What does that integral give me? Oh wait, and I actually need to go next. I need to go 15 minutes. And what does that integral give me? Because it's T and 0 is May 1st. So, what does this integral tell me?
How many cars will the lot?
How many cars function. Writing A of t and S of t is good for your work. So, what is this? Tell me then. Now, how many have been added to the lot minus how many have been taken off the lot? What is this still not taking into account? How many started on the lot? So there are a couple of ways you could word this. You could find this integral. If it's greater than or equal to 0, there's more than it's greater than or equal to, if it's greater than 0, then there's more than 100. If it's less than 0, it's less than 100. Or you're in your work, you could put a 100 plus, and then find that value. And what is that value? 157. It's 257. You don't have to. There's two ways you could word this, but you would need to if you don't put the 100 plus. Oh, sorry. If you don't put the 100 plus, then this needs to stay greater than 0 because you're saying you added cars to the 100 that were already there. They work either way, but you need to use one of those reasonings because we do have to explain our reasoning, don't we? We are well along the way of explaining our reasoning, but we do need to write a little sentence there, right? And what do we need to say? And there's like 100 different answers to this question. More cars are added than are taken away, or something like that, right? Doesn't have to be exactly that wording, but something about word. Again, there are probably 100 different ways we could word that.
So if it said justify, would you have to say something else like
I would say justify and explain both would look okay here. Both of those words that I think are, because when you do justify or explain, they are grading mathematics as well. So they won't grade a sign chart, but they will grade work as part of your justification. That 257 being greater than 100 is, they're going to read that and go, okay. Write an equation to represent the number of cars on the lot. If you did part A the way I did part A, part B is really easy. If you did part A some other way by just saying something about A of t, the integral from 0 to 14 of A of t being greater than the integral from 0 to 14 of S of t, then part B would be a little tougher. So it kind of depends on how you work part A on how difficult part B is. But I need to write an equation to represent the number of cars on the lot at any time t. So I'm going to call it, have they used C? Cars on the lot, you can use any function you want to, is 100 plus the integral Now, just a little math technicality. AP will not count off for this, but a college professor might. You can't technically use the same variable of integration as your limits. It's just kind of one of those things that you're not supposed to do. AP will grade it and they wouldn't count off. But I would change this to 20x, or you could even write 8x. Not a big deal. Again, if you use T, AP would give it to you, but a college professor would count off for that because your variable of integration can't be the same as one of your limits. So I just changed the variable just so I'm not using the same one. Any questions about that? So I want to add the number of cars that are being assembled and subtract the number of cars that are leaving the lot. I have seen this problem on way more AP tests than I would like. They changed the problem, like cars on a lot to grass clippings and snow and different things that are accumulating somewhere. Last year, I think it was, no, I can't remember last year. The year before it was grass clippings. The year before that it was snow. So they're going to have what we're going to call an accumulation problem on almost every AP. Any questions about that one? Or 0 to 30, and I would say even if they don't ask you to do part B, if you have to do part C, you need to think about part B. For 0 to 30, at what time is the cars sold on the lot a maximum? Well, how do you find maximums? You look at endpoints and you find the derivative and set it equal to 0, right? Well, what's the derivative of this?
It would be A of x minus x.
A of t minus s of t? No, because you made the change when you found c and t, but it became a t there. Well, then think about it. What's the derivative with respect to t of this? Remember, you put that t in. Any questions about that before I go on? Where'd the 100 go? It's constant, the derivative of constant 0. The 100 does not affect the rate of change, right? One of the most common mistakes on this is to try to think about the derivative without thinking about the original, and people will accidentally throw the 100 in or do some weird things like that. So I would recommend think about that even if it doesn't ask you to before you do that. Set that equal to 0. Again, we're going to use a calculator. Essentially, I'm setting A of t equal to S of t, correct? In my calculator. They were 20t times 2 to the negative 0.2t and 30 plus 15 cosine of 0.2t. Make sure your calculator's in radians, physics people. Only if you're using something in trig. Right? You're not using something in trig. It only matters if you're doing cosines. They're probably peaks at certain times of the day or peaks at certain times of the month. But I don't know. Someone's smarter than me figured that out. Okay. Any questions so far? 0 to 30. So I'm going to find where those intersect between 0 and 30. And you might show the reader that's what you're doing. Show the AP reader that that's when t is approximately 21. Now you could use that graph, especially if you had done it using subtraction. To eliminate one of those is probably a relative minimum. But if you don't do that, that's okay. It's up to you. We are then going to do it a what? When we are doing absolute maximum, what do we do every time? Candidates test. Good. We check the endpoints and check the values. Again, if you eliminated this down to 1 because of relative maximum, that's great too. If you didn't, that's okay too. Just plug all 3 or all 4 of them in. in a problem like this where you get a calculator, it's not that big a deal to plug them all in. Where am I plugging them all into? What in your calculator?
Oh my gosh.
The original equation, C of t, right? Because I want to know when C of t is a maximum. On my work, remember this says justify, so on my work I'm going to be very clear on what I'm doing. I'm going to show C of 0, C of 21.044, C of 3.309, and C of 30. I already know C of 0 is 100, so I can kind of save some calculator steps that way. Other than that, I'm going to plug this in my calculator. Either use your y equals or use your arrow back up. You know how you can just go change the t in your home screen? You can just go grab it and change t. Does anyone not know how to do that? Anyone not know how to do that? Like you scroll up and go push enter and it brings it back down and you can change t. Or hit second enter and it'll bring the last step down.
Oh, that. Okay.
Or you can just scroll up and grab it.
Okay.
And what did we set for C of 21.044?
145.52.
Okay, and 3.0 or 3.309.
188.6.
Say it again.
183.6.
Okay, and then 30. Are you plugging it into that?
Oh, wait, no.
What?
Okay, so hit in your calculator. Well, I don't know where you plug it to. Where do you plug it? And what is this secret? C of when two people doing this and doing it wrong, I think you should all try and make sure you can do it right. Now the 21.044, we didn't store that value. Everyone listen to this really quick, because you need to know when that's okay and when it's not okay. I'm going to argue that it's okay that we didn't store that value because this did not ask me what is the maximum amount of cars, it just asked me when. So my y value doesn't have to be accurate. Does everyone know what I mean by that? If it did need to be accurate, they were asking what is the maximum number of cars, I would go back and store that 21.044. Does everyone know how to do that? From the graph, to store from the graph. You go to your home screen and type X, store as, and it'll use the X from the graph screen wherever you left it. Okay, what did you get for 21.044? Is that what you got?
No, I got 854.
I was like, you did this.
Okay, So stop and look. We watching? Everyone watch. Okay, we're going to do, I want to do C of T, which you have written on your paper, I hope. It's this thing right here, right? Now, if you want to type that in your y equals just so you can retype the number in, you can. But you can type it in your home screen. So I'm going to do 100 plus the integral. Alpha zoom, or alpha window number 4. From 0. I'm not going to waste my time doing from 0 to 0 because I know what the answer will be. It'll be 100. So I'm going to skip to the 21.044. A of x, or A of t, which is 20. And if you want to use x, you can. If you want to use t, you can. That's up to you. Times 2 raised to the negative 0.2 x dx minus the integral from 0 to 21.044 of s of t. So let me pull this back up. So minus the integral from 0 to 21.044 of s of t, which is 30 plus cosine of plus 15 cosine, sorry, of 0.2 t, or x is what I'm going to use, dx. And I'm going to push enter. And I got negative 26.47 at 21.044.
Yeah, 21 should be 4.
Uh-oh. I don't know. My calculation. I teach grade 2. Yeah, did you get 354? So I'm not teasing when I say your calculator has to be in radians. Okay, now to do the other 2, that took me quite a while to type it in. I don't want to type it in again, so I'm going to go up and grab it. And I'm going to go back and change the 21.044 to be, what am I supposed to change it to? 30? And I get 177.753 or 4. And then also you could do y'all have already decided that the 3.305 was a relative minimum, I think, but if you wanted to do it, we could go ahead and type that in and find that value also. 3.305. $35.767. Okay? Okay, so we got on 21, remind me what we got, 357. 354. When I did 3, we got 35. Now again, you have to be more clear if it asks you to actually find the maximum value. It just wanted us to find where the maximum happens at. And C of 30 was, so, at what time is the number of cars on the lot a maximum? T is approximately 21.044. Now, just for mental note, it didn't ask, but what does that mean?
May 20th, like 2 a.m. in the morning.
Almost, wouldn't it be May 22nd? So it would be May 22nd, right? and sells them at a rate of 1 plus 6 sine of 2 pi t over 41. Not me. This actually is a real AP practice.
Just think about cheesesteak.
They're just
Yeah, I don't like that.
Okay. Hey, BC calculus children. Okay. Now, what time is the number of steaks ready to sell at a minimum? So you notice this is a common AP problem type where they do these rates of change problems. So at what time is the number of steaks ready to sell a minimum? Well, what are you going to do to find a minimum? Find the derivative, set it equal to 0, and check the endpoints, right? Well, what is the derivative? No, hold on.
the chain rule, Miss.
The rate, right? The rate is the derivative, right? These are the rates. This is the derivative, right? Okay, this is the derivative. So, we are cooking at 4 steaks per minute and selling at 1 plus 6 sine of t steaks per minute. So the cheesesteak derivatives, right? The rate of change of how many cheesesteaks we have is the 4 minus the 1 plus 6 sine of 2 pi over 40, 2 pi t over 41. So that is the derivative. Be careful with that. Good question. Where does the plus 25 come into play? On the... Remember me telling you, even if they don't ask you for the original, you need to think about it. Do I need to think about the original here? And what is the original?
25 plus
That's the derivative.
Let's just go ahead and be... well, you can give it a name. Okay. Right? Now this is the most honest problem. You can write whatever you want. But to get to the original, I need an antiderivative, right? And then I need to take the... Joseph said,
Gotta take chain rule.
Joseph said, when does the 25 come into play? Well, that comes into play only on the amount of cheesesteaks, not on the rate of change of the cheesesteaks. Does that make sense? So you're going to set this one equal to 0, and then you're going to plug in 0 and 30, right? You're going to check the endpoints, and you're going to check the critical points. Try that. That's not going to work. 20?
Wait, what?
Oh, the answer is 20?
No,
Oh, what did I say?
30.
Oh, 0 to 20, yes. 0 to 20, not 0 to 30.
So why do we keep the normal one?
You're going to have to do the absolute minimum, right? You're going to have to find when is the number of steaks ready to sell a minimum. Now, you might can tell that just by looking at the derivatives, right? If you look at a nice derivative graph, thinking about area. So you might can tell that without actually doing a candidate's test. So you might not have to write the original function, but you do need to think about it.
Okay, and this might be a dumb question, but why are you doing the integralize and not just the antiderivative of it?
That is the same thing.
Oh.
The integral and the antiderivative would be the same. Right? Not big deal.
Wait, so
Okay, well, this is just going tomorrow. We'll do a couple of AP practice read the answers on it, but